Alright, in this video we're going to be talking about section 6b, measures of variation. In the last video we looked at measures of center, mainly the mean, median, and mode of a set of data. Now we're going to turn to quantitative measures of variation. Okay, so why does variation matter? Alright, let's take a look at this scenario here. Let's say we want to consider the following wait times for 11 customers at two banks. Okay, one would be Big Bank, which is 3 lines, and Best Bank only has 1 line. And these are the wait times for 11 customers at those 2 banks. Which bank is likely to have more unhappy customers? Okay, and in this case, if you look at these 2 histograms here, you'll see that Big Bank will have more unhappy customers, because with 3 lines, you can see here there's more long waits there. But with the Best Bank, there's only 2 cases where you have waiting times here. So Big Bank will be more likely to have unhappy customers. Okay. Now let's start off with this example, and this is just a kind of a review of what we talked about in the last video here, leading up into measures of variation. In this case, you want to find the mean and median for the waiting times at Big Bank given below. Show your work clearly and verify that both are the same. Okay? Now, the following values are measured in minutes, and these are the data values for Big Bank with 3 lines, as you can see. Now, the first question is, which of the following shows how to compute the mean? Now, if you recall in the last video, we did talk about what a mean was. The mean, you take the total number of values and divide that by the sum of all the values. You sum up all the data values, divide that by the total number of values that you have here. So, in this case, it would be answer C. Sum of all values divided by the total number of values. Okay, and now we're going to find the sum of all the values here. Well, we just simply add up these numbers that we have in that particular data set. So here, if I add 4.1 to 5.2 to 5.6 plus 6.2 plus 6.7 plus 7.2 plus 7.7 plus another 7.7 plus 8.5 plus 9.3 plus 11.0. You'll end up with 79.2. So here the sum of all the values is 79.2. The total number of values is, well, let's count up how many data values that we have here. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We have 11 data values. Now let's calculate the mean to 1 decimal place. So if I take 79.2 divided by 11, you'll get 7.2. So the mean is 7.2. Okay. All right, the next part of that question here is, notice that the data are given in ascending order. How should the median be found in this case? Select the correct choice below and fill in the answer boxes to complete your choice. Okay. Now there are 11 data values here, so that tells me we know we're going to have only one number in the middle. Here we have an odd number of data values. That tells me the median will automatically be in the middle. Okay, so the median in this case is going to be the first plus the 11th number divided by 2. So if I add 1 and 11, that's going to be 12. 12 divided by 2 will be 6. So that means the median will be the 6th number in that data set. So to find the median, we count to the 6th number in that data set. So here I'm going to do 1, 2, 3, 4, 5, 6. There's your median, 7.2. So the median there is 7.2. And then the final part of that question here is the mean is either less than, equal to, or greater than the median. Well, compare the median of 7.2 with the mean of 7.2. They're both equal to each other. So the mean is equal to the mean, the median. The mean is equal to the median. Okay. Okay, example 2. Find the mean and median for the waiting times at Best Bank given below. Okay, just like we did in example 1. Which of the following shows how to compute the mean? Well, has to be this one. You take the sum of all your data values. That sum is divided by the total number of data values that you have. So it's that particular formula that we talked about in the last video. Now let's take the sum of all the values here. Okay, so here we're going to do 6.6 plus 6.7 plus 6.7 again, plus 6.9 plus 7.1 plus 7.2 plus 7.3 plus 7.4 plus 7.7 plus 7.8 plus another 7.8. You'll get 79.2. So the sum of all the values is 79.2. The total number of values, well, let's count how many we have. 11. So the total number of values there is 11. Okay, and again, if we take 79.2, which is your sum of all the values, divided by the total number of values, which is 11, you'll get 7.2. So the mean is 7.2. Okay, and again, you notice that the data values are given in ascending order. How should the median be found in this case? Well, that's similar to the last example there. You take the first data value plus the 11, add them together, divide by 2. So 1 plus 11, that's 12. 12 divided by 2 would be 6. So the 6th number in that data set is your median. So here the median will have to be, what's the 6th number in that data set? Well, let's count 1, 2, 3, 4, 5, 6, which is going to be 72. So the median is, 7.2. $7.2 will be your median. Now, the mean is either less than, equal to, or greater than the median. Well, compare the median with the mean. You can see that the mean is equal to the median. So we select equal to there. Okay. All right, on the next page, we're going to talk about something called the range of a set of data. We'll start with the easiest measure of variation, which is the range. Now, the range of a data set is a difference between its highest and lowest data values. So the range is going to be the highest value minus the lowest value. Okay. So now in example 3, the table to the right gives the cost of living index for 6 East Coast counties and 6 Midwest counties, using an index where 100 represents the average cost of living for all participating cities with a population of more than 1.5 million. Here we're going to answer parts A through E below. Now, with this example, I've broken it up into separate parts here because in this example, there are other things that we need to talk about more. So here, example 3 is broken apart like this. Only in part A, you're going to find the mean, median, and range for each of the 2 data sets. Okay? Here we're going to find the mean for the East Coast counties. Okay, and these are my data set for East Coast counties, as you can see in that table. To find the mean, we just take the sum of those data values, like 104.9, 128.6, 314.9, 134.3, 123.4, and 141.3. That sum is 947.4. Now there are 6 data values that you see here. We need to take that sum of 947.4, divide that by 6. And it will be, now they say the 2 decimal places, so here on the calculator I got 157.9. Well, if we wanted to 2 decimal places, it's going to be 157.9, and I have to add a 0 behind it. Otherwise, they're going to give me a wrong answer because I'm not following the directions of rounding the 2 decimal places. And now for the median for the East Coast counties. Now, median, you know you got to put your data set in numerical order from least to greatest. Okay, now, this is going to be my data set sorted for the East Coast counties. Now, I've already sorted it out, so here it is. We start with the lowest, 104.9, 123.4, 128.6, 134.3, 141.3, 314.9. Now the median is going to be the middle number. Okay, so if I cross out the first and the last, then the first and the last, notice I got 2 middle numbers, 128.6 and 134.3. That median will be the average of the 2 middle numbers here, so I had to do this. I got to take 128.6, add 134.3. That sum will be divided by 2. So here, 128.6 plus 134.3, that'll give me 262.9. Divide that by 2, you're going to get 131.45. That will be your median for the East Coast counties. 131.45. And now for the range for the East Coast counties. When you're finding the range, you have to take the highest number or the highest value minus the lowest value. As you can see up here, that's how you find the range. The highest value is 314.9 minus the lowest, that's 104.9. And you can easily get your highest and your lowest if you sorted the data from least to greatest. So 314.9 minus 104.9 will give you a range of 210. And they did say round the 2 decimal places, so I need to carry this out to 0.00. So the range for the East Coast counties is 210.00. The mean for the Midwest counties, these are my Midwest counties right here from U to Z, okay? To find the mean, we add those data values of 96.4, 92.2, 94.5, 87.7, 95.6, and 228.3. That sum is 694.7, and there are 6 data values there. We're going to divide by 6. That will give me, to 2 decimal places, 115.78. That's the mean. And now for the median, okay? So here, I'm going to put the sorted data set down here for the Midwest counties, okay? And I've already got this sorted out, so I'll go and write down that sorted data. 87.7, 92.2, 94.5, 95.6, 96.4, and 228.3. That's my sorted data for the Midwest counties. Now, if I find the median by eliminating the first and the last numbers on both ends, you can see that 94.5 and 95.6 are the 2 middle numbers. And to find the median of that data set, we take those 2 middle numbers, add them together, divide by 2. So I'm adding 94.5 to 95.6. That sum will be divided by 2. So here, 94.5 plus 95.6 will give me 190.1. Divide that by 2, you're going to get 95.05. That's going to be the median for your Midwest counties, 95.05. And then the range of the Midwest counties. For the Midwest counties, if we're finding the range, we take the largest data value of 228.3 minus the smallest, the lowest data value of 87.7. And we're going to carry that out to 2 decimal places as well. 228.3 minus 87.7. That's going to be 140.6, and we need to carry out to 2 decimal places by adding a 0. So it'll be 140.60 for the range. Okay. That's how we find the mean and the median, and also the range of a data set. Okay. Next we'll look at quartiles and the 5-number summary. Okay, the lower quartile or the first quartile divides the lowest fourth of the data set from the upper three-fourths. It is the median of the data values in the lower half of a data set. Okay? Now, the middle quartile or the second quartile is, of course, the median of the entire data set. Of course, when you find the median, you're finding the middle number, which will be the middle quartile. Sometimes they call it the 50th percentile. And then the upper quartile will be the third quartile that divides the lower three-fourths of the data set from the upper fourth. It is the median of the data set in the upper half of a data set. Okay. Okay. And using the lower quartile, the middle quartile, and the upper quartile, we can also come up with what they call a 5-number summary. So this is what we'll talk about here, the 5-number summary. All right, the 5-number summary for a data set consists of the following 5 numbers. You have the lowest value, then your lower quartile, then the median, that's the middle number, then your upper quartile, and then the highest value. Okay? Now, we can use a 5-number summary to draw what they call a box plot. Okay? A box plot will have the 5-number summary visually with a rectangular box enclosing the lower and upper quartiles, a line marking the median, and whiskers extending to the low and high values. Okay? Now, an illustration of what a box plot would look like, it could look something like this. Okay? Because it has a box, and then you got your whiskers on the ends, on both ends. Okay? The one on the far left will be your lowest value. This box creates the quartiles here. The first line would be the lower quartile. This line inside the box is your median. This line right here is going to be your upper quartile, and it's going to be extended by another whisker, which will have the high value on the far right. Okay? That's what the box plot looks like. Okay? Now, when we draw a box plot, we're going to draw a number line that spans all the values in that data set. And then second, enclose the values from the lower to the upper quartile in a box. The thickness of the box has no meaning. And then number 3, draw a vertical line through the box at the median. And then number 4, you're going to add your whiskers. Your whiskers are those horizontal lines with short vertical segments at their ends, extending the lowest and highest values. Okay? All right, now, this is the continuation of example 3. And that deals with those East Coast counties and the Midwest counties. Yeah. So here we're going to use that data set that we just did in example 3, which is this right here. Okay, so this is going to be the continuation of example 3. Okay, so here we're going to give the 5-number summary and draw a box plot for each of the 2 data sets. You're going to select the one that fits that data set. Okay, for the East Coast counties, 3 of these are going to be quite easy. And I say that because the low value, if you did sort this data set in numerical order like we did here, if you remember that, we're going to deal with the East Coast counties. You can see the low value is 104.9, and the high value was 314.9. Okay, and they want these to two decimal places here. So that low value was 104.9 with a 0 behind it. The high value was 314.90. Okay, now that's coming from this data set right here, and I've already sorted this out when we did part A of example 3. Also, we can get the median. When we found the median, that was the middle number. For East Coast counties, that median is 131.45. So about 3/5 of the problem we've already done. Now we need the lower and the upper quartile. Okay? Here I'm going to give you that sorted data that we had for East Coast counties, which was 104.9, 123.4, 128.6, 134.3, 141.3, 314.9. Okay. Now we know the median is in the middle of these two. Okay, we know the median was a 131.5. That's in the middle. So this is your lower set of numbers. These are your upper set of numbers. From the lower set, we're going to find the lower quartile, which is the median of the lower quartile, or the middle number. This is going to be easy because the middle number in this lower quartile that we're going to be looking at is the 123.4. And I have to add a 0 behind it. Okay? And now for the upper quartile. This is the upper end. We need its median, or the middle number. In this case, 141.3. So it'll be 141.30. Okay, so those are our, that's the 5-number summary. And now we need to choose the box and whisk, well, the box plot that best fits that 5-number summary. And by looking at this, it will have to be C. The reason why I chose C would be this. The median is 131.45. That will be there. The median is this bar that's inside the box. I know it can't be A because the median is right here. And also that lower quartile is 123.40. This one has somewhere between 130 and 150. So A is out. And I notice that my lines are here in B, the highest and the lowest data value. So it can't be B, has to be C. Okay, let's talk about the Midwest counties here. We're going to find the 5-number summary for the Midwest counties and choose the correct box plot for the Midwest counties below. Okay, I'm going to go back to that sheet that I had for the Midwest counties. That's the sorted data for the Midwest counties here. 3 of them we already know. The lowest is 87.7 and the highest is 228.3. So I can go ahead and fill in the low value, which was 87.7. And the high value was at 228.3. And I do need to put a 0 here because they say the 2 decimal places as needed. The median, well, we did part A of example 3. The median for the Midwest counties was 95.05. So we can fill that in as well. Okay. And then we go ahead and copy down that sorted data again. For the Midwest counties, that was 87.7, 92.2, 94.5, 95.6, 96.4, 228.3. So now we can find the lower and the upper quartile. Okay. We know the median is between the 94.5 and 95.6. So let's look at these numbers on the low end, 87.7, 92.2, and 94.5. The lower quartile is the median or the middle number of the values that are in the lower end of this data set. In this case, it's going to be 92.2. And then for the upper quartile, this is the upper end. Let's find out what the median is, or that middle number. It's going to be 96.4. And it'll be 96.40. Okay. And now we're going to find the box plot that best fit that 5-number summary. Okay. The upper value is missing, the highest value is missing, so we can leave out B. And look at what C looks like. There's something missing here in that box. The box is not even there in C, so we can eliminate that and choose answer A. Because if you look at these data values here, these lower values right here are less than 100. The low value, the lower quartile, median, and upper quartile are less than 100. And that 228.30 is way out there. Okay? So that's how we do a 5-number summary and create a box plot. Okay, now for the standard deviation. The standard deviation is the single number most commonly used to describe variation. It is the measure of how far the data values are spread around the mean of a data set. Okay, the standard deviation does measure how far the data values are spread around the mean of a data set. And this is the formula for finding the standard deviation. It is equal to the square root of the sum of your deviations of the mean from the mean squared divided by the total number of values minus 1. Okay? If we complete these 5 steps right here, we can easily come up with the standard deviation. The first step is to compute the mean of the data set. Okay? And then you're going to find the deviation from the mean for every data value. By doing this, the deviation from the mean will be the data value minus the mean. After which you're going to square all the deviations from the mean. Okay? You're going to find the squares of all the deviations from the mean. And then next you're going to add all the squares of the deviations from the mean. That's the sum of the deviations from the mean squared. Divide this sum by the total number of data values minus 1. So if you have 11 data values, it's going to be 11 minus 1 in the denominator, which will give you 10. You'll take the sum of those deviations divided by 10, for example. And then finally, you'll take the square root of that quotient. That will give you the standard deviation for that entire data set. Okay. So now let's look at the continuation of example 3. And this is going to be for East Coast counties and Midwest counties. All right, so now we're going to find the standard deviation for each of those two data sets, following that procedure that I just gave you. Okay, let's start with the East Coast counties. I'm going to label this as East Coast. We've already found the mean back in part A of this example 3. And I'll remind you, for East Coast counties, the mean for the East Coast counties is that number, 157.90. That's your mean, okay? Now we're going to take each value, and that's of course that data set that we have here from part A of example 3. I'll copy those down again. That's 104.9, 128.6, 314.9, 134.3, 123.4, and 141.3. Now to find the deviation of each one of those values, we're going to take the data value minus the mean. Data value minus the mean. So here, if I do 104.9 minus 157.90, that will be negative 53. And then 128.6 minus 157.9, that's negative 29.3. And then 314.9 minus 157.9, that'll be positive 157. And then 134.3 minus 157.9 will be negative 23.6. And then 123.4 minus 157.9 would be negative 34.5. And then finally, 141.3 minus 157.9. That would give me negative 16.6. Okay. Each of those are the deviations for each data value, because it's a value minus the mean, the data value minus the mean. And now for the deviation square. I'm just going to take the square of each of those individual deviations here. Now keep in mind, when you square a negative, you're always going to get a positive value. So if I do this, left parentheses, negative 53, close parentheses, and square it, you're going to get 2,809. Notice I had to put parentheses around negative 53. If I left that out, like here, I'm going to get a negative number. You want to make sure you have a parentheses, and the square is on the outside of the parentheses. So we got 2,809. And then for negative 29.3, close parentheses, square it. The x squared means you're going to square it, and then hit enter. That'd be 858.49. And then 157 squared would be 24,649. And then it's a negative, so left parentheses, negative 23.6, close parentheses, and hit the x squared to square it. You'll get 556.96. And then negative 34.5. And then square it would be 1190.25. And then finally negative 16.6. And then square it. You'll get 275.56. Now for this last column will be the sum of the squares of your deviations. You're going to add these numbers together. So 2809 plus 858.49 plus 24649 plus 556.96 plus 1190.25 plus 275.56. That total is 30,039.26. That's the sum of the squares of your deviation. Okay? And now we're going to take this number of 30,339.26. That's going to be divided by, here we got 6 data values, so it's going to be the number of data values minus 1. That was step number 5 in your in what I gave you here. Which means this number will be divided by 5. 30,339.26 divided by 5. That would be 6,067.852. And now finally, to get the standard deviation, we're going to take the square root of that number, 6,067.852. So second x squared for the square root. Second x squared for the square root. And we can go ahead and type this in over if we want to. Now, this is going to be to 2 decimal places, so this will be 77.90. That will be the standard deviation for your East Coast counties. Okay? All right, now we're going to do the standard deviation for the Midwest counties. And you know what, to save time, I'd rather do this on the calculator. If you have a TI-83 or the 84 plus graphing calculator, you can find the standard deviation here. And let me show you how to do that, okay? My Midwest counties are these data values right here. Let's start by pressing this button that says Stat, S-T-A-T. If you press the Stat key, we're putting in new data values here, so I'm going to select number 1 under the Edit menu for Edit. I got stuff here in this computer, in this calculator. What I need to do is clear it out. I'm going to use my up arrow key to highlight L2 in this case, then press the Clear key, and then Enter. I'm going to do the same thing for L1. I'm going to use my left arrow key to go to L1. Use my up arrow key to highlight L1, press Clear, press enter. And in L1, I'm going to type in these data values here. So it'll be 96.4 for Midwest counties, and then 92.2, enter, 94.5, enter, 87.7, enter, 95.6, enter, 228.3, and then enter. You want to make sure you press enter after each and every single data value that's given to you. Okay. And now I'm going to press the stat key. I'm going to use my right arrow key to go to the calc menu or the calculate menu. The one I'm going to select is number 1, one variable statistics. So I'm going to select number 1 for one variable statistics. That list will be L1 because that's where my data values are located in L1. Don't worry about the frequency list, you just skip over that. Highlight calculate using the down arrow menu and then press enter. Now, for the standard deviation, the one you want to select is the one that says an X, an S, as in Sam, with X, not this one. It's this one you want to select because that's the one that this calculator is using based on the formula that I gave you earlier. S sub X will be your standard deviation that you want to use. And as you can see, in this case, it is 55.21. So for the Midwest counties, it's going to be 55.21 for your standard deviation. Okay. Now, the one I did for the East Coast counties, you can do that in the graphing calculator as well and get practice on that. You'll see it will give you the 77.896, I believe, but I rounded it to 77.90. Okay. Okay. And by the way, I will be posting something on Canvas, a handout or a file that shows you how to use the graphing calculator to come up with the one variable statistics. But you want to use SX. S is in Sam, followed by the lowercase x for your standard deviation. Okay. All right, next we're going to interpret the standard deviation using what they call the range rule of thumb. Okay. Now, the standard deviation is approximately related to the range of a distribution by the range rule of thumb. Now, here they use this formula for the standard deviation. It's going to be approximately equal to the range divided by 4. And of course, the range is the highest data value minus the smallest data value divided by 4. That difference will be divided by 4. Now, if we know the standard deviation for a data set, we can estimate the low and high values as follows. Here, the low value will be approximately the mean minus 2 times your standard deviation. Your high value will be the mean plus 2 times the standard deviation. Okay, that's how we find what we call the minimum and the maximum usual values here. Okay. And if you have to take a full course in statistics, we do talk about finding the range of usual values, okay? Because that represents the fact that 95% of the data values fall within 2 standard deviations of the mean. And we did talk about the empirical rule in one of the videos here, the 68, 95, 97% rule. Okay, we're going to use that standard deviation where the range is, where we take the range and divide that by 4 in this example. Again, this is a continuation of example 3. Apply the range rule of thumb to estimate the standard deviation of each of the 2 data sets. How well does the rule work in each case? And discuss why it does or does not work well. Okay, the standard deviation for your East Coast counties. Okay, now I'm going to have to do this at the top because I didn't provide it. Well, I could do that. Well, let's do it at the top. And I'm going to abbreviate SD for the standard deviation. That's going to be the range divided by 4. Well, the range for your East Coast counties, guess what? We've already found that. Okay, so I'm going to go back here to find example 3A. Here it is. The range for your East Coast counties, that's 210. Okay, so we're going to take 210, divide that by 4. And that will be 52.5. I'm going to add a 0 because they want this to 2 decimal places. So the standard deviation for the East Coast counties is approximately 52.50 using the range rule of thumb. And then for Midwest counties, the same thing. They want us to use the range rule of thumb. So your standard deviation will be the range of your Midwest counties divided by 4. Well, notice here, the range of the Midwest counties is 140.60. So let's take 140.60, divide that by 4. That'll be 35.15. So your standard deviation of your Midwest counties is 35.15. And how well does the rule work in each case? In this case here, I would have to select answer D. And the reason for that is they do not work well in both of these two data sets because there are outliers in both of the two data sets. And if you notice in your data values here, in the East Coast counties, here's your outlier, 314.9 here. For Midwest counties, here's an outlier, 228.3. Those are far away from the other data sets, data values in that data set. And part E, based on all the results, compare and discuss the two data sets in terms of their center and variation. And you want to select the ones that apply. Let's say for the mean. If you look at this, the mean of COLI for the 6 East Coast counties is higher than the mean for the 6 Midwest counties, which means the average level of COLI for the East Coast counties is higher. Well, that makes sense. Here it is. For the East Coast, that mean was 157.90. For Midwest, it was 115.78. Okay? So we can select that. And for the variation, if you look at the standard deviation from this, you can see for East Coast counties, that standard deviation is higher than the standard deviation for the Midwest counties. So we can select this answer as well. And that means the level of COLI in most Midwest counties varies in smaller range. Okay. And I think they want the range. They're probably looking at the range right here. 210 and then 140.60. Okay. So this is all of example 3. Okay. Now, here's a full-blown example 4 of everything that we talked about in this video. Okay, the The table below shows the fraction of games 1 to the nearest 1,000 by 6 professional teams in the East Coast and West Coast leagues for the 2016 season. The list includes the teams with the best and worst win-loss records in both leagues. And we're going to complete parts A through E below. Okay, so there's the data set for East Coast teams and West Coast teams. Guess what? We can do all of that in the calculator. Well, most of it we can do in the calculator. Finding the mean, and I think the median, we have to kind of sort the data set in numerical order. We'll see what we can do here with this calculator here. All right, let's start off with the East Coast teams. We're going to press the Stat key, select number 1 for edit, and I'm going to go ahead and clear out what's in L1. So use your up arrow key to highlight L1, then press clear, and then enter. Clear it out. Now let's enter the data values for the East Coast teams. This will be 0.412, and then enter. 0.464, enter. 0.483, enter. 0.522, enter. 0.575, enter. And then 0.631, and then enter. Okay. And now, here's what we're going to do. Press the Stat key. And then I'm going to go to the Calculate menu, or the Calc. I'm going to select number 1 for one variable statistics. Your list is going to be L1. Don't worry about the frequency list. Highlight Calculate using your down arrow key, then press enter. The mean there, if we were to round, it's right here. That X bar is the notation for mean. If we were to round that off to 3 decimal places, it'll be 0.515. So the mean would be 0.515. Okay, now notice this arrow down here on the far left side. That means that there's more stuff on this on this calculator that the screen can only fit. So if you use your down arrow key, guess what? Here's your median right here for the East Coast teams. Round that off to 3 decimal places, it'll be 0.503. Okay. Okay, now for the range. Well, the maximum value was 0.631. The minimum value was 0.412. We'll have to subtract those. And when you subtract those, you can get 0.219. That's going to be the range here for the East Coast teams, 0.219. Okay, now let's look at the West Coast teams. We need to change our data set here. So we go to Stat, press Stat key, and then we're going to edit, so we need to select number 1. We're going to clear this out by using the up arrow key in L1. Press enter. No. It's highlighted. Press clear and then enter. Up arrow to highlight L1, clear, and then enter. Now let's enter those data values for the West Coast teams. This will be 0.366 and then enter. 0.423, enter. 0.500, enter. 0.575, enter, 0.585, enter, and then finally 0.584, enter. And then we're going to press the Stat key. Use your right arrow key to go to the Calculate menu, and then press enter. Okay. I actually selected number 1. You can press number 1 for the one variable stats, or press enter. Okay. L1 is what I want. Frequency list. Don't worry about that. Highlight Calculate, press enter. That X bar is your mean. To 3 decimal places, it will be 0.506. Now for the median, if I use my down arrow key to go to locate what's in here, that's actually my 5-number summary. Here the median is 0.538 if we round it 3 decimal places. And the range, let's take the maximum, which was 0.585, minus the minimum, which was 0.366. This will give you also 0.219. So 0.219 is your range for the West Coast teams. Okay, next is part B. Give the 5-number summary and draw a box plot for each of the data sets. Okay. Now this is going to be for the East Coast teams. Okay. That's going to be this data set way up here for the East Coast teams. So I know where my median is. It's going to be here. These numbers on the bottom are the lower end. These numbers on the right will be the upper end. I need the midpoint of the lower end of this data set. That's going to be that 0.464. That's the lower quartile. And then going back here for the upper quartile for this, I need the midpoint there. That's going to be 0.575. Okay? And for the East Coast teams, it's already in numerical order from least to greatest. Okay, now the lowest value was, for this, 0.412. That was your lowest value. The highest was 0.631. The median was that number, 0.503. Okay. Now we have to pick the one that's closest to this 5-number summary. Okay, let's see. Based on this, it'll have to be D. Has to be D. Because I know C would not be it, because this highest value is somewhere between 0.2 and 0.4. That's not close to 0.6. And on B, this one is past this right here is your median. That's around 0.4. We got 0.503, so that's not it. And A, the lowest value is less than 0.4, and we came up with 0.412. We can eliminate that. Has to be D. Okay. And now, for the West Coast teams, this I have in the calculator. The lowest value is, as you can see, 0.366. The median, we're going to say 0.538. That Q1, that's your lower quartile, by the way, 0.423. The upper quartile, Q3, 0.584. And the highest value was 0.585. Okay. Now, if you want to, you could sort that data value for the West Coast teams in numerical order. and I have to put 0.584 first. And then 0.585. The median somewhere in the middle. On the lower end, 0.423 is your lower quartile. The upper end, 0.584 is your upper quartile. The lowest value and the highest value, and we did find the mean, the median of 0.538 in Part A. Okay, so that's your 5-number summary. Now the next page continues this by wanting the box plot that fits this 5-number summary. In this case, because 0.584 is 1/1000 less than 0.585, it will have to be this one right here, D. Just for that particular reason. Okay. And now we're going to find the standard deviation of each of the data sets here. Let's see, for the East Coast teams, and I should not have deleted that data set. I'm going to do this. I'm going to put it in what we call L2. Press that key, and then number 1. That's for the West Coast teams in L1. In L2, I'm going to put the East Coast teams there. So, let me go back to that data set and re-enter those. 0.412, and then 0.464, and then 0.483, 0.522, 0.575, 0.631. That's going to be the East Coast teams. Okay? The one in L1 will be the West Coast teams. So if I want to find the standard deviation, I'm going to do this. Press the Stat key. Highlight the Calculate menu. Select number 1 for one variable statistics. Now instead of L1, I'm going to change this by selecting number 2. I want to change that to L2. Oops, big mistake. Okay, L2 in this case is in blue, so I need to press second and number 2 for L2. Second and number 2 for L2, because I want the data values that are in L2, and then go down to Calculate, and then hit Enter. Okay, the one that I want to select is the capital S with an X behind it. This is your standard deviation. That's going to be 0.079. 0.079 for the East Coast teams. And now for the West Coast teams, I stored this in L1. So I'm going to do this. Press the Stat key, go to Calculate, and then select number 1. I'm going to change this by doing second and then number 1 on your calculator. Second and number 1 to change it to L1. Use your down arrow key to highlight Calculate and then press Enter. You'll see that S with the X, that's your standard deviation of the sample, 0.093. That will be the standard deviation. Okay. Now, Part D, apply the range rule of thumb to estimate the standard deviation of each of the data sets. Okay? So now, for the East Coast teams, I'm going to pull out a blank sheet of paper here. For the East Coast teams, that range, the standard deviation would be the range of the East Coast teams divided by 4. Now going back to Part A, the range of the East Coast teams was 0.219. So I take 0.219, divide that by 4. I'm gonna get this number right here. To 3 decimal places, it'll be 0.055. Okay. And now for the West Coast teams. And that's for East Coast, and this is for West Coast. Again, range divided by 4. That range for the West Coast teams, range for the West Coast team was 0.219 as well. So I'm going to get the same approximate standard deviation of 0.055 as well. Okay. All right. Now, how well does the rule work in each case? Here, the data values are not distributed evenly. Okay. Yeah, there's not an even distribution here by just looking at it. So, the rule does not work in both cases because the data is not distributed evenly. Based on all your results, compare and discuss the two data sets in terms of their center and variation. Here, the mean is higher for the East or West Coast teams. Therefore, the center of the data is larger for either the East or the West Coast teams. Let's go back to this. Let's look at the mean for the East and the West Coast teams. You can see for the East Coast teams, the mean is higher than the mean for the West Coast teams. So here, the mean is higher for the East Coast teams. Therefore, the center of the data is larger for the East Coast teams. And then the other part, the standard deviation is higher for the East or the West Coast teams. Let's see. Oh, I can go back up here. We can see here the standard deviation for the East is, 0.079, and for the West is 0.093. So the standard deviation is higher for the West Coast teams. And therefore, the variation is larger for the West Coast teams. Okay. All right. That will conclude this particular video on measures of variation.